Let's take a look at these problems out of 3.2. They give us an equation, and they want us to find three ordered pairs that are solutions to this equation, and then they want us to plot this. So I'm going to make a table, and in my math lab, they're going to give us some x values. For example, they're going to give us an x value of 0. And they might also give us an x value of b, and they might give us a y value. So let's find the other part of our ordered pair for each of these. So when x is 0, we're going to substitute a 0 into our formula. We'll put a 0. Notice there's still a y in our equation. So what we're trying to find out is when x is 0, what is y? Well, notice that 0 minus y is just minus y. Just like anything plus 0 is that number, anything minus 0 is that number. Well, if we have 0 minus a number, our answer is just minus that number. So 0 minus y is just minus y. If we want to get rid of the negative, we can divide both sides by -1 or multiply. A negative divided by negative makes it positive. Anything divided by 1 is itself. Positive divided by negative is -6. So we let we get y is negative. Sometimes at this step, we say if the opposite of y is 6, just take the opposite of both sides. That means y would have to be the opposite of that, which is -6. So that gives us the first ordered pair, 0, -6. Now let's go to the next one. It's 3. So we're going to take the same formula, x minus y equals 6, and put a 3 for x. So we want to get y by itself, so make the 3 go away. So the opposite of a plus 3 would be to take away 3. 3 minus 3 cancels, leaving us minus y. 6 minus 3 is 3. Well, if negative y is 3, y is the opposite of that, which is -3. We could show dividing or multiplying by a negative, but if the opposite of y is this, then y is the opposite. Just take the opposite of both sides. And then they give us a y value. So this time, instead of plugging in for x, we're going to plug in for y. Y is -4 equals 6. Notice each time we substitute into the formula, we put a parenthesis around it, and that helps us make sure we get our signs right. So our formula is x. So x minus, and then the y value is also negative. So minus a negative, we'll change that to a +4. If we want to get x by itself, we do the opposite of 4, so we take away 4. 4 minus 4 is 0, so that leaves us with x. 6 minus 4 is 2. Y is negative. It goes with an x of 2. So once we get that, then we can graph this. Let me see. Here's the graph here. Yeah. So if we plot these points, we have 0, -6. So 0, -6, we go left and right none, go down 6. 3, -3, we go over 3, down 3. So over 3, then down 3. And 2, -4, so go over 2, then down 4. Over 2, then down 4. And then we can just draw a line through those points. And we can extend it in both directions. Now, technically, we only need 2 points to determine a line, but it's good to have 3 points because if we know we're supposed to have a graph that's a line and our points are not in line, then we know one of the points is wrong and we can go back and check it. What do I mean by that? If we have a point here, and a point there, but it's supposed to be a line, notice those are not in line with each other. So at least one of those points has to be wrong, so then we could go back and check it. But here our points are in line, so that's what our graph will look like. All right, then they ask us to graph this one. So if we make a table, let's pick various values. Notice in this equation, y is by itself. If y is by itself, then I'm going to pick numbers to plug in for x. So like 0, 2, and 4. That way, since y is already, when we replace x with a number, our y is also by itself. So the corresponding y value is just whatever we get when we simplify the right. So if we plug a 0 in for x, negative 2 times 0 is 0. 0 plus 3 is 3. So when we put a 0 where x goes, y is 3. Now let's put a 2 where x goes. So in place of x, let's put a 2. So this time we get negative 2 times 2 is negative 4 plus 3. So when x is 2, we get that y equals opposite signs. So we subtract the numbers, take the sign of the bigger. So negative 1. And then let's do one more. So this time we're going to let x be 4. So when we put a 4 in for x, y is negative 2 times 4 plus 3. Opposite signs, so subtract the numbers. 8 minus 3 is 5. Take the sign of the bigger number. So that gives us 3 ordered pairs, so we can plot that. So we have the ordered pair 0, 3. So over none, down 3. I'm sorry, 0, 3, over none, up 3. Then we have 2, negative 1. So over 2, down 1. Then 4, negative 5. So over 4, down 5. And then we can draw a line through that. And if we put those in the correct spot, then our line should go through all 3 of those points. And I just put little arrows on the ends. So that's the graph of that equation. Every place that line touches is a point that is a solution to that equation. Okay, so let's graph this one. Now, we can leave it in this format, and we can graph it just like it is, or we can get one of the variables by itself. And it really doesn't matter which variable we get by itself. So we could get x by itself. Normally, we get y by itself. But on this one, notice the only thing we would have to do to get x by itself would be to add 2y to both sides. So minus 2y plus 2y, those would cancel. The other side, we would have 8 plus 2y. So if we make a table so that we can get some points to graph, notice we have x by itself. So this time, instead of picking numbers for x, let's plug numbers in for y, and then our x will be whatever we get when we simplify the right side. So let's just pick 0, 1, and then maybe negative 2. So if we replace y with a 0, If we put a 0 where y is, x would be 8. 2 times 0 is 0. So x would be 8. All right, this time let's put a 1 in place of y. So 8 plus 2 times 1. So let's find x when y is 1. So x would be, we multiply before we add. So 2 times 1 is 2. So x is 10 and y is 1. And then lastly, let's put a negative 2 in place of y. So 8 plus 2 times negative 2. Again, we have to multiply before we add. So 2 times negative 2 is negative 4. And then 8 minus 4 is 4. So that gives us 3 ordered pairs that are all solutions to that equation. Those are not the only ones. We could pick any x and there's a y that goes with it. Or we could pick any y and there's an x that goes with it. So if we plot these points, we have 8, 0. So go to the right 8 and then don't go up or down any. Then we have 10, 1, so go over 10 and up 1. Then we have 4, negative 2, so go over 4 and down 2. And connect those. So any place that that line touches is a point that's a solution to our equation. You could put a dot anywhere on this graph and anywhere that any ordered pair that our line touches would be a solution to that equation. Okay. So let's graph this one. This one is a little bit tricky because notice there's not a y in this equation. If there's not a y in this equation, then that means y can be any number as long as x is 3. For example, y could be 0 as long as x equals 3. Y could be 4 as long as x is 3. Y could even be negative 7 as long as x equals 3. So y can be any number as long as x equals 3. So let's graph that and see what that would look like. So the first ordered pair is 3, 0. So that's over 3, up and down 0. Then 3, 4. That would be over 3, up 4. And then 3, negative 7. So over 3, down 7. So if we draw a line through that, that's a vertical line that goes through an x value of 3. Anytime we have x equals a number, that's a vertical line at whatever that x value is. All right, let's graph this one. And we can make this a little bit easier on ourselves if we really look at our equation. If we just randomly pick any number for x, that's okay, but that also could make us come out with fractions. So let's think about what 1/2 times x means. If x is not a fraction, we could still make it a fraction by putting it over 1. So we could call this minus 1/2 times x over 1. And then a minus 1 on the end. We don't have to necessarily say that. But the reason sometimes I'll write it this way is when we pick numbers for x, we want to pick numbers that can be divided by 2. So you might also would rather call it, remember when we multiply fractions, we multiply the tops and the bottoms together. So we could call this 1 times x over 2 times 1. So all of these are the same. And the reason that some people like to write it this way is so that when we pick a number for x, it's helpful if we pick a number for x that's divisible by 2. Now, any number we can divide by 2, but some of them we get remainders for, or decimals. But if we pick numbers like 4, 2 goes into 4 evenly, 6, or even 0, all of those numbers evenly can be divisible by 2. Now, some people might be okay with this original and say, well, as long as x is even, when I take half of an even number, I'm going to get an integer. But let's use the bottom one. So if we put a 4 in for x, we get y equals negative 4 over 2 minus 1. So 4 over 2, 4 divided by 2 is 2 minus 1. So if we replace x with 4, we get that y is negative 3. Now if we take that same equation and replace x with 6, then y is minus 6 divided by 2, which is 3, and 3 minus 1. Remember, if the signs are the same, we add the numbers, take the sign of the bigger. So we would get minus 4. And then y equals minus, put in a 0. 0 divided by 2 is 0. Minus 0 is just 0. 0 minus 1 is negative 1. 0 divided by anything is 0, so that goes away, and that leaves us with minus 1. So let's plot that. So we have 4, negative 3. So 4 down 3. 6 minus 6 is negative 4, so over 6 down 4. And then 0, negative 1. So over 0 and down 1. And if we draw a line through that, notice those points are in line with each other. Like that. So that's the graph of that particular equation as well. So on this one, they give us the graph of y equals 4x. So let me draw that. If we graph y equals 4x, the graph looks like this. And then they want us to graph y equals 4x minus 6. 4x minus 6. So, different things we could do. The easiest thing to do here would just be to make a table. So if we put a 0 in for x, I'm just going to do this real quickly. 4 times 0 is 0, minus 6 would be minus 6. If we put a 1 in for x, if we replace x with 1, 4 times 1 is 4, minus 6, those have opposite signs, so we subtract them, take the sign of the bigger. And then if we put, let's say, a 3 in, we would get y equals 4 times 3 is 12, and then minus 6, which is 6. So we would get 0, negative 6, so over none, down 6. 1, negative 2, so over 1, down 2, and 3, 6, over 3, up 6. So that line will look like this. And what they're wanting you to notice is that those lines look very similar. Y equals, let's see, this one is y equals 4x minus 6, and the other one is y equals 4x. Notice the equations are very similar, and the lines look very similar. They run beside each other at the same angle, the same steepness, the same slope. They just have different places where they cross this vertical line. And this vertical line we call the y-axis. This horizontal line is the x-axis. This vertical line here, that's the y-axis. And one thing that is mentioned is that if we have our equation solved for y, the number that doesn't have an x with it, 0, comma, that number tells us where our y-intercept, where we touch the y-axis. So for our new line, notice 0, negative 6 is one of our points. That's called the y-intercept because that's where our graph intercepts the y-axis.